Hello and welcome to the 3D Amateur channel. Today I'm going to make a square, I'm going to make a box, and I'm going to put a hole in the box. And I'm joined by Sam, who taught me how to do all of this in FreeCAD. So stick around and you can see how we did it. So here we are in FreeCAD. I'm joined by Sam, who's taught me everything I know and is going to help talk us through this time-lapse of me learning FreeCAD.
Yeah, I'm going to try and do my best. This was a lot of fun. I really enjoyed myself.
Yeah, so did I. It was a good live stream, to be fair. Just a shame about having mic issues, but that's fine. We've solved them. So if you do want to join us on our future live streams, you can. Just head over to twitch.tv/3D_amateur, and the link will be in the description. So I'm a complete novice in FreeCAD. So with the experience that you have, what would you say is the most important thing to understand when you first start in FreeCAD?
Well, I think the most confusing thing for a complete beginner is the interface. I think that's something that you really need to get your head around. So all of the tools at the top, for example, change when you change workbench, which we can talk about later. But the model tree on the left, that is, you really need to understand that.
Yeah, I mean, 100%. That was the thing that I got confused about most. When I first started playing with FreeCAD on my own before we had our live stream, I opened up a couple of model files, that like the example files that they had, and looking at that model tree on the side was a nightmare. But I think you probably explained it in the best way that I remember, which was PPB, which is Project, Part, Body. And you have a project, which is your overall model. You then have your parts within that project or within that model, and then you have your bodies, which are make up your parts. And then you said there was like another layer down from that as well, which is
and then sketches are what create bodies.
Yeah.
So your sketches are your 2 dimensions, and then your body is your 3-dimensional, or is your third dimension.
And then your bodies combine to make the parts, and the parts combine to make the model. So, yeah, it's once you understand it, and it is literally a tree that branches out, it makes so much sense.
It's very logical. It's a very, very logical layout. But yeah, if you were to just open up a really complex model right off the bat, it would be very overwhelming. Yeah.
Yeah, 100%. For the purposes of the training me in FreeCAD, and for the purposes of 3D printing, we just really wanted to create a single solid object. So we had a part, and then we created a body, and then we're going to edit that body. And the way that we do that is by creating a sketch. So there's a little button at the top there, which is like the white square with the red square and circle on it, and that will then create a sketch. So when you create a sketch by clicking that button at the top, you then have to choose a plane. And you have the 3 options, which is your XY plane, your XZ plane, and your YZ plane. For the purposes, again, of 3D printing, which is what I'm learning this for, we're always going to use the XY plane, because that is the plane that will effectively be your print bed when it comes to exporting this model as an STL and then importing it into a slicer. So you select your sketch, you select the XY plane, and then it will take you to this screen. So if you could explain a little bit more about what we're looking at here, because this is the Sketcher workbench, isn't it?
Yeah, so now we're looking at the XY plane that you've chosen from a top-down view, and we're going to draw a sketch on that plane to turn into a 3-dimensional object.
And for the purposes of this tutorial or this explanation, we decided we were going to make a cube. So the 2-dimensional version of a cube is a square, and quite simply there's a tool at the top that allows us to make a square.
Yeah, so what we've done, we've taken that square and we've extruded that in the Z plane, we've extruded that in the Z axis to turn it into a 3-dimensional object. However, we've done that, taken many, many shortcuts. So now what we need to do is reverse the process and then look at how we constrain the sketch and follow the proper practices.
So going back to what you just said about extruding, So when you extrude an object on that z-axis, you do that with the pad function, isn't it, in FreeCAD, which is named slightly differently to most programs.
Yeah, most CAD programs are called. It's called extrude, so it's kind of like universally known as that. But in FreeCAD, it's called the pad tool. Basically, we just took a lot of shortcuts and we created a 3D object out of the 2D sketch that wasn't properly constrained. So now what we were doing, we were going back and we're actually going to set up the proper constraints and follow the correct practices.
So the constraints, as I understood them when you were explaining, is the degrees of freedom of movement that this particular two-dimensional object has. And to make it exact and to give it the exact dimensions that we want, we need to put in place constraints. And this prevents movement where we don't want it. Is that correct?
Yes. Yeah, no, yeah, that is correct. Yeah, the two elements really is the size and the position of the object. So the FreeCAD needs to know the size of every length and every point, and then the position of it relative to the datum or the origin.
So for the purpose of this particular square, we decided to make it 30 millimeters across, and that's where we used that constraint tool from the top there. We selected the two lines, top and bottom, and then we put in 30 millimeters, and then that removed one of the degrees of freedom. So by doing that, that means that now that's always going to have that same height. And you can see on the left there, it does say under constrained sketch with however many degrees of freedom, and as we start constraining it, this will go down to 0, and then it will be a fully constrained model.
And it will turn green.
Just like that. However, we did make lots of unnecessary constraints at this point, and you taught me an easier way to do it with the symmetry tool, wasn't it?
Yeah, we were just sort of playing around, understanding what the constraints are, what they do, how they're used, and there's various ways you can constrain the same shape. So that's what we were just trying to demonstrate.
So then here we use the symmetry tool to align it with that center line or that center datum. So if we refer to datum, it's usually a point of reference is probably the easiest way to explain it. And that can be any number of points or things within the model. So for the purposes of this, it is that center line. Again, we initially used the symmetry tool to make it symmetrical left and right and up and down, but this was also unnecessary. And again, the whole purpose of this was to learn the best way to do this. So I initially started with constraining the size, then constraining the center point to the outside points up and down, and it was a lot of constraints for something that would be easier done with only a few. So you then said about diagonal constraints, wasn't it?
Yes, yeah. So if you were to constrain two diagonal corners with the origin, it would not be able to move left or right, provided you've got your sizing constraint there.
So by reducing the number of constraints, we're reducing the complexity effectively and just making it easier to work with.
And I think that's something else that's really important as well. Like on the outside of every single one of these edges, there's a tiny little red line. So that is a vertical or a horizontal constraint. If we didn't have those, it would be able to twist and move and do all sorts of crazy stuff.
So now it's turned green. That means that it is a fully constrained sketch, and we can see that reflected on the left-hand side where it now says fully constrained sketch. So what this means is we've got our exact measurements, it's constrained, and the program basically knows exactly what it is and what it's supposed to be. And then when we go back to the three-dimensional view or the pad, now this is perfectly aligned with what we want as a 30mm by 30mm square. And then it is extruded up on the z-axis, and by default it extrudes by 10mm, but to create the cube we obviously wanted to extrude that to 30mm, which is what I've done here. So now we have a perfect cube. In the interest of understanding again the modelling, so I wanted to create a hole in the cube. So can you explain a bit about that process?
Yeah, so like how we created the cube in the first place, we had a sketch and then turned that sketch into 3 dimensions. So we need to use the same methodology here and draw a 2D sketch of the hole that we want to create. and then use that in a three-dimensional sense to remove the material.
Which is known as a pocket. So what I wanted to create was I wanted to bore a hole through the cube. And to do this, we basically need to start a sketch again, but this time we're going to do it on the YZ plane. And to make this a lot easier, you can actually hide all of the previous models. So we can then create our sketch without any other interference or any other model or object being in the way. And we do exactly the same process. We go through the sketch, we make it constrained, a bit simpler with a circle than it is with a square. And then once we have that, we then use the pocket tool. And what this will do is pocket or create a hole in the object. So it's basically the opposite of the padding or extruding. Would you say that's a fair assessment?
Yeah, no, exactly, yeah.
In this particular case, we actually wanted it to pocket on both sides of the plane because we wanted a hole all the way through. So as you can see here, it's actually just put a hole from one side and pocketed from that one side through the end of the cube. But to make it go through both sides, we can just press that symmetric to plane button, and that will basically give us a pocket on either side of the plane we've selected.
Yeah, so it's quite crucial to sort of nail down that the plane that we're sketching on is in the middle of the cube. Usually, that may not be the case. You may actually be sketching on the edge of the cube, or on the edge of the face. In which case, you wouldn't need to do it symmetric to plane. You would just go from one end to the other. But because the plane is going through the center, you can then pocket effectively in both directions.
So this will vary from model to model then, really. It just depends on what you're designing and what your end goal is. For the purpose of this, I just wanted to make a hole all the way through, so it made sense to have the plane in the middle and just extend from both sides, or remove material from both sides. But if you wanted to do, say, a hole for something to go into, like a pen or something like that, it would probably make more sense to do it on one of the faces of the cube and then pocket into the cube.
Yeah, in most cases you do have to, yeah, I'd say.
So once we've got to this point, we've made a cube, we've made a hole in the cube, and from a 3D printing perspective, there's something called horizontal expansion, which you can adjust for in the slicer settings, but this basically means that when you're printing with material, the first layer is always squished a little bit more than the rest of it, and sometimes this results in something called the elephant's foot, and this means that the first layer or the first couple of layers tend to be wider than the actual measurements of the model. And one of the best ways to avoid this is, rather than using the horizontal expansion slicer settings, is actually just to chamfer the bottom edges of the model, which if you're designing your own model, obviously this is very easy to do, but if you're just downloading a model from somewhere, it becomes a little bit more complicated. So that was the next thing I asked, and where you can see on the screen here, we can select faces, we can also select edges, and then we can use the Fillet Tool, wasn't it?
Yes. The Fillet Tool or the Chamfer Tool.
So what's the difference between the Fillet Tool and the Chamfer Tool?
So the Fillet Tool adds a radius, which is what you can see right now. And the Chamfer Tool will just cut a straight line from 2 points. So at the bottom, you have a chamfer, where it's just chopped a chunk of material off of that edge in a straight line. And then what you've got on the hole is the fillet, where it's a radius.
So with the chamfer tool, you can just bring them edges in, and that will just accommodate that extra first layer squish to prevent that horizontal expansion on the first layer. So this was something that, from a 3D printing perspective, I really needed to know, or wanted to know, for creating my own models. And we kind of experimented a bit here with breaking the software effectively, wasn't it? It was finding the limits of what we could do.
What you need to remember is that FreeCAD is trying to calculate what all of these features are going to do, and it's trying to compute them and render them in this three-dimensional space. And some things are physically impossible. So if you just start messing around with features and shapes too much, you can break the model. Yeah.
Yeah. So again, as a novice at all of this, it was a very valuable tool experimenting with this and understanding where them limitations are. so that I could understand exactly what it was that I needed to do, especially for the chamfer creation and things like that.
I think that's part of the fun of it as well. I think I would encourage everyone to do that, just to play around and just, hit those features and just see what you can do with it.
Yeah, absolutely. I agree. Because after we created this model, I went on to create a new model, and I created my own calibration cube. So just using the knowledge or what I'd learned making this cube and creating these features, I then went on to create a 20 by 20 millimeter cube and added the X, Y, and Z onto it, which is a whole nother video because we can talk about datum planes and how we, pocket letters and things like that. But yeah, just by using or just by learning this, I was then able to experiment further and create something entirely new and something different. So yeah, that is exactly part of the fun. It's just playing and understanding. And sometimes you'll come across something that you have that eureka moment, and you're like, aha, that's how I do that.
It should be fun, and these are not easy programs to learn, and I think you need to remember that they are complicated and they are different. So yeah, just you've got to enjoy it. Otherwise, what's the point?
Exactly, and it was good fun learning this with you on the live stream. It was entertaining to say the least. Yeah,
it's an experience for me too.
If you would like to see them live streams, then again, head over to twitch.tv/3D_amateur. There'll be a link in the description, and yeah, you can join us. We haven't got a set schedule yet, but we're working towards it. And yeah, hopefully you can jump in, say hi, and give us some advice, or maybe learn something new,
or just have a laugh.
Yeah. If you do want to learn a bit more about FreeCAD and the different things you can do with it, then you can always head over to Sam's channel as well, JesterEngineer. So he's going to start doing some more FreeCAD videos and just sort of experimenting with the program itself and some of the clever things you can do with it. I think you have a FEA video up at the moment. So what's FEA?
Finite element analysis. It's a simulation technique which is used to literally simulate real world conditions. So you will have what you're trying to do is look at outputs for a given set of inputs, and that could be forces, it could be temperatures, and then you're looking at how that model is going to react. And it's an intermediate step between designing and then physical testing within industry.
And I think this is actually one of the main reasons that we picked FreeCAD to learn on, because to use FEA in something like Fusion 360 or other programs, they are paid for programs, whereas FreeCAD is free. It's in the name. So being able to have all of that functionality can make the world of difference when you're designing models.
Yeah, what FreeCAD can offer as an open source program is absolutely incredible, really.
Absolutely, and I look forward to many more sessions of you teaching me the workings of FreeCAD, and I look forward to starting to design my own models for 3D printing. I'm quite excited.
Yeah, it should be fun. Well, it is fun.
So yeah, if you'd like to see more of these FreeCAD videos, then you can head over to Sam's channel at JesterEngineer. And if you want to watch us live, you can head over to twitch.tv/3D_amateur. Links for both will be in the description. So yeah, hopefully you can join us there. So if you did like this video, then don't forget to hit that like button. And if you do want to see more, then you can always subscribe. If you have any suggestions for improvements, then leave it in the comments below. Thank you very much for watching. Hopefully I'll see you again. Take care and have a good day.